Assalamualaikum and good day, madam. For the project of ITT 569, our group have worked on smart farms with title IoT Solutions for Farmland Alert System. For this project, we have three objectives, which first is building a system for real-time alert. So for the first objective, we are focusing on two things. First is detecting trespasser using PIR and IR sensors. And the second one, fire hazard detection to the farmhouse using smoke detector. So the input from those sensors are then fed into a system, enabling real-time notification to the user via Telegram and web, which is fulfilling the objective number 2. So the third objective is creating a database to store data systematically. So for that reason, we are using XAMPP-based database. Hardware requirement for the project is as listed, and the total estimated cost for this project is 300.
So on the software side, we relied on Audio IDE for coding and uploading program to the microcontroller. So for data storage, we use XAMPP to create a centralized database, and Telegram bot API was integrated to send real-time notification for user iPhone. And finally, we develop a web interface using Visual Studio for living monitoring and historical data visualization.
Assalamualaikum. This slide illustrates the IT control system flow process. The sensor, PR, infrared, and smoke are connected to the microcontroller. The microcontroller acts as the central unit processing data from the sensor. Detected event trigger action such as activating alarm or spotlight. Eventually data is sent to a cloud database, XAMPP. We use XAMPP via Wi-Fi, enabling real-time monitoring on the website, and Telegram notify the instant alert directly to the user mobile device, ensuring a responsive and seamlessly system. Next slide. Here we present the system block diagram. The system starts with the sensor detecting motion or smoke. The signal are sent to the microcontroller, which process the data and determine the appropriate action. The microcontroller activate the alarm and spotlight while simultaneously logging the data into the database, and also the alarm will trigger and on site. The data is displayed on a real-time web dashboard and trigger notification to Telegram for instant update. This structure ensure efficient communication and monitoring. This is a flowchart represent the operational logic of the system. The process begin with the sensor detecting motion or smoke. In an event detected, the system activate the alarm and spotlight. Simultaneously, the data is processed and stored in database. Notification are sent via Telegram, and the data is updated on the web monitoring platform. Lastly, the reset button allow the user to normalize the system and restart the flow for continuous monitoring.
For development process, we have 5 points here, which is the first one is requirements gathering and planning. We will select the suitable sensors for this project, which is PIR sensors, infrared, and smoke. And the second one is hardware setup. We need to connect everything with the microcontroller, which is ESP8266 Arduino. So we will ensure the proper wiring and proper sensors. Then we will test the sensor function. Okay, the third one is software development. We will program the microcontroller to process the data and develop the notification system integrated with Telegram API. Then we set up the database to store the sensor using XAMPP. And the next one is for web and mobile integration. We will create a web interface for real-time data visualization using HTML, PHP, and SQL. So we will link the database to the website for the dynamic updates. Then we will test the Telegram notification for real-time alerts. Okay, the last point is testing and deployment. We will test the entire system sensors for the real-world environment. So we will verify the motion detection, fire alerts, and notification accuracy. Then we will deploy the system for monitoring and gather user feedback for improvement. Okay, here is the sample for development process. As you can see here, we have the screenshot there.
Okay, next let me explain how to test the system to ensure it works effectively. So first, we test each component individually. For example, the PIR sensor, we start by moving an object in front of it to ensure it could detect motion correctly. So then we test the smoke sensor using controller smoke to check its sensitive. So after confirming the components work individually, we integrate them with the ESP8299 during this phase. So we verify that the sensor could send data to the microcontroller, trigger the Telegram notification, and log the data into the database. Okay, and finally we could file testing in a real farm environment. So the PIR sensor successfully detect animal moving such as a chicken, cat, or maybe like an elephant with a 99% currently red. The smoke sensor also detects smoke from a 5-meter distance, which is ideal for small farmhouse. Okay, so let me talk about the result for our testing. Okay, our testing relate the following result. The arrange time for sending notification to Telegram was 2 seconds after detect, and the motion detect was 99% current red, which smoke detail achieved on at 5% currently red under normal condition. So overall, the system performance while it both control and real world environment. However, we noticed some challenge such as smoke sensor currently in wine condition. Let me start by summarizing the problem statement that led to the develop of our project. So if you can see, we have 3 problem. For problem 1 is animal trespassing. In farm, animal trespassing is a common issue that damage crop and lead to scientific financing loss. So farm need a solution that can detect and deter animal without harm them. So the problem 2 is a fire hazard. Fire in farmhouse or fire can be devastating, not just for property, that also for crops and living stock. So early detection of smoke or fire is critical to prevent such incident. And the last one is a problem 3 is a real-time monitoring. Many farms lack a system that provide a real-time monitoring and alert, and especially it remove area where connection is limited. Okay. Now let's move on the conclusion and recommendation for the project. So for our conclusion, our IoT-based smart alert system addressing there's challenge effectively. So by integrating PIR infrared sensor, we provide accurate red motion detection to prevent animal trespassing, and smoke sensor enable early detection of fire hazard, ensure the safety for farmhouse. So the through the Telegram notification and web-based monitoring system, farm can monitor their farm in the real time, even remotely. So so for the recommendation, the system work well. We identify area for improvement. So for first, expand connection option. So improvement identification communication method such as SMS alert or LoRaWAN to ensure the system work in area with poor internet so coverage. And two is integrate energy efficient integrate solar power to make the system suitable and operation in remote area without relay electric. Third, enhance detection correctly. Use AI technology to improve motion detection by distinguishing between human and animal, as well as reduction species fire farm. And the last one is explore ways to scale the system for large farm or multi-location monitoring. So in our conclusion, in this project has a successful demonstration and affordable, efficient, and scalable solution to address key challenges faced by farm. So by adapting the recommended enhancement, the system can become even more impactful in safeguarding crop and ensure farm safety.